Let's do a chem quiz involving isotopes. I'm going to take the two isotopes of oxygen, oxygen 16 and oxygen 18, the atoms, and I'm going to put them in a flask. So the same number of oxygen 16 and oxygen 18 atoms in a flask, I'm going to let them react to form oxygen molecules. The question I have is, after the molecules are formed and we do a mass spectrometry run, what will the mass spectrum of the product oxygen molecules look like? Think about that for a second and make a selection. Let's consider an argument for each of the possible options. Option A, the three combinations O16, O16, O18, O18, and O16, O18 are all equally likely. Or B, the combination of O16 with O18 occurs twice as frequently as the 16, 16 and 18, 18 combinations. Or C, O16 and O18 will not occur as a molecule because different isotopes don't react. Consider those arguments for each of the answers and make your selection again. Our problem was oxygen atoms in a flask, two different isotopes, oxygen 16 and oxygen 18. They're going to react to form oxygen molecules. So I'll get oxygen molecules with three different masses. If an oxygen 16 reacts with an oxygen 16, that gives me an oxygen molecule of mass 32. If an oxygen 16 reacts with an oxygen 18, an oxygen molecule of mass 34. And if an 18 reacts with an 18, an oxygen molecule of mass 36. So what's the distribution of masses? Well, let's look at this problem. If I bring an oxygen 16 and allow it to react with another oxygen 16, that gives me a mass peak at 32. But each oxygen 16 could also react with an oxygen 18, giving you mass 34. But you have to think about what happens with the oxygen 18s as well. An oxygen 18 could react with an oxygen 18, giving mass 36, or it could react with an oxygen 16, giving another mass 34. It turns out it's actually twice as likely that you get the 16-18 combination. It's the same thing in this physical example where I have blue and red chocolate-covered candies. If I mix them together, equal numbers of each, and then pick them out at random, what kind of combinations would I get? Well, let's pick out one with each hand. If I reach in and I pick out a blue, and I reach in with the other hand, there's two possible combinations. I could pick out a red, or I could reach in and pick out a blue. But what if this hand first picked out a red? Well, the same thing could occur. I could pick out a blue, or I could pick out a red. So the combination of red-blue occurred both times, regardless of what was in this hand. It's twice as likely that the red-blue combination occurs, just like in an equimolar mixture of oxygen atoms. So this physical example is exactly like the molecular example of oxygen forming out of oxygen 16 and oxygen 18 isotopes. The correct answer is it's twice as likely that the 16-18 combination occurs. And it's always likely that chocolate-covered candies are incredibly delicious.